Good morning, everyone, or wherever you are. So, thank you for taking the time to listen to what we've got to discuss on microgrids and the journey to sustainable AI data centers in Europe. So, we'll just start through now. So, just a quick agenda, really, of what we're going to discuss. So, microgrids, a definition of what a microgrid is. A peaker versus an energy center or microgrid. So I will call a microgrid perhaps an energy center and things like this, but microgrid and any energy center is the same definition. New technology. When is a microgrid required? Technology, prime power, ancillary technologies to reduce the environmental impact, fuels and sustainability, DC hero and villain, key criteria, and the impact of load, and then just some conclusions. So I think the first thing is just to define what a microgrid is. So microgrid, energy center, power station, they're all terms used interchangeably. So a microgrid for AVK is more than just an energy center, because we're looking at a DC application. So this microgrid only has one purpose, and that's to serve power to a data center. So the power can range from 5 MVA, it can go even lower. We're actually looking at some fuel cell technologies for clients with lower requirements, right up to 400 MVA. But the key definition, a microgrid is built to serve a specific load. It's not connected to the network to act as a peaking plant to provide inertia onto the grid. We think of the microgrid as got to be able to support the load of the data center. Deployment, depending on the technology we use, can go from 12 months or it can go up to 2 years. So just a bit of a definition, sort of clarification. So a peaking plant is not a microgrid. A peaking plant has an assigned amount of operating hours, normally 1,500, 2,000, 4,000, and they're connected to the electrical network to boost power output in times of demand and also to trade on the network as a market resource. So they're a money-making venture onto the network. So there's no defined resilience. When they're called into service, they'll start up. There's no penalties for them not being available, and they have much lower operational hours. A microgrid for a data center is 8,760 hours operation per year. We're guaranteed to support a design load. So a lot of discussion about AI, larger language models, all of these sort of things, they introduce a different kind of load. So it's not a base load. We may be looking at a load that fluctuates. And the microgrid's designed to achieve a defined resilience. So the microgrid will give you X amount of resilience and be concurrently maintainable without affecting service to the load. So just microgrids, they're not new technology. Microgrids have been connected to the network in different forms for many years. These serve power plants. These power plants are connected to the network and they switch on and off. But as I said before, a microgrid is defined for its sole purpose of feeding the data center load. So just some examples. So combined cycle gas turbine energy center, high-speed energy center, which is a modular solution, dual fuel energy center, which is using medium-speed combustion engines, and a medium-speed energy center in Germany. So just some examples, some images of some microgrids. So when we look at an energy center, it sort of forms what we call the power stack. So the energy center, if you're network restricted, it'll feed the data center, and then we've got ePods and standby power and all the service and support requirements around that. So when would you need a microgrid? So just listening to the last talk about sovereign AI and all this sort of good stuff, is all of these facilities require power. So if the network's not available to give power, you could use a microgrid. If the network power is limited, so for instance, you want 100 MVA, you can only get 10 MVA, you can use a microgrid connected in parallel with the grid. The connection date is not suitable, so we call that a bridging system. So you want to get online for 2028, 2027, but your network doesn't come available until 2030. You can use a bridging microgrid to support renewable energy. So this is a key one, is the growth of renewable energy, so PV, wind, requires inertia-based technology to sit behind it. Otherwise, you're going to, when the wind's not blowing and the sun's not shining, you're going to need these inertia-based tech to support the grid. Network support. So a microgrid can be dual functionality, so you can feed the data center load, and then with any surplus energy, you can put that back to the grid. Energy resilience. So I think we're, pretty much all aware that grids are becoming constrained, transmission is becoming an issue, and we can't rely on the grid as much as we used to. So a microgrid gives you energy resilience. Governance and accountability. So you can be truly accountable for the emissions that you create. So you can actually say, these are the emissions, these are what we're doing to account for it. We can bring in lovely renewable sources of electricity to balance on the microgrid. So governance and accountability. Trigeneration. So trigeneration is use the efficiency losses from, say, for instance, a combustion type system, and you use that to cool the DC. District heating schemes. This is something as standard we're doing with a lot of our equipment, is we're making them ready for connection to provide free hot water for district heating, which increases the efficiency of the microgrid. Again, this is just going again, is when is a microgrid required? So these are just the key points to say, look, if we hit one of these 8, 9 items, we need to think about getting a microgrid onto online. So AVK, we've been in business for well over 30 years in the DC market. We're technology agnostic, so we're not looking to provide you a certain technology because we're a manufacturer of that technology. We're technology agnostic, so we look at your load, your deployment type, your location, the permitting and planning requirements, and we'll look to try and give you the best technology. So that can range from solid oxide fuel cells, medium speed engines, high speed engines, turbines, energy storage, and we've also got our eye on SMRs as future technology, but we've still got a little way to go on those. The key with any microgrid is the ancillary technologies that you use to increase efficiency, lower emissions, capture carbon, and to be a good neighbour. So AVK are able to offer carbon capture. Carbon capture is not a new technology. Carbon capture has been, available for many, many years. We can, capture the carbon, and we can either go to CCU or CCS, so carbon capture utilization or carbon capture storage. If we're using a combustion engine, or in some cases a turbine, we can use selective catalytic reduction to reduce the emission levels. and we can use tri-generation, district heating schemes, all of this sort of thing to that it's adding the technology, it's building a solution that meets all of the requirements. So fuel considerations, because we're a microgrid, because we have to be available 24 hours a day, 7 days a week, we have to think about our choice of fuel. So one of the common questions I'm asked by clients is, are your systems hydrogen ready? Yes, they are. 100%. All of our systems that we're looking for are hydrogen ready. So because obviously we want this transition from a fossil fuel to a cleaner fuel, reduces emission, it helps everything. But when you're looking at a microgrid, we've also got to think about fuel delivery. And when we say fuel delivery, this isn't fuel being delivered to your site. This is connected to the fuel network of the country. And at the moment, natural gas is the most available. Most countries have a hydrogen roadmap. The first stage is going to be to blend in hydrogen into the natural gas network. So a 20% mix of hydrogen into the natural gas network to reduce emissions of all of these assets across. The new assets, the microgrids that are coming online are so much cleaner. So they're so much technically advanced, emission controlled. We sit right in the best available techniques for the microgrids. We also like to blend into the microgrid renewables. So when we're talking with a client, if they want 20 MVA, then we'd look to, maybe offer 5 MVA of renewables, mix that into the microgrid. So when the sun is shining, we're offsetting. And we can also look at a biogas microgrid. So the biogas doesn't mean that you're injecting this gas directly into the microgrid. It's offset into the network, and you can have biogas with carbon capture as well. So fuel choice is key, but most countries at the moment in the world are natural gas until the hydrogen roadmap sort of plays out. So we consider microgrids, sort of coming through a scope of enlightenment, shall I say. So microgrids really are emerging technology. So we hear everybody talk about AI data centers, the power required, what loads needed, how they're going to scale it up, the importance of these AI data centers on the large language model systems. Microgrids are going to play a key part in this journey because networks aren't going to catch up that quickly with requirements for data centers. And I think it's important for every country to understand is there's a limited window for this sovereign AI platforms, and each country is going to want to host their own AI platforms. So just threw this one in quickly, and I'll just touch on it. This is our client microgrid roadmap. So basically, what AVK do is we identify the client requirements, which is the criteria. We issue a microgrid sales concept, and then we assist with the planning support. So we've got to think of our key gatekeepers as permitting for your emissions and planning. So we've got to tell the story of the benefits of what you're going to get. And we've also got to describe the microgrid as future fuel ready. We're doing everything we can to make these things as clean, as efficient as possible. And we're ready to accept the next stage of fuels. So that's just a quick one on that. So this is just a narrative on hero or villain data centers, because you see a lot in the news at the moment is with regard to data centers, requiring huge amount of power, huge amounts of water. And I think there's some uneducated sort of opinions or narratives on this. So we think it's important to change the narrative. So data center as a villain would be a data center user like utilizing the grid. So if a data center just requests 150 megawatts of power from the grid. The network gives them 150 megawatts of power. They're adding to a problem. They're going to increase electricity prices for all of the clients. So that's all of the normal people connected to the grid using power. If we're putting huge lumps of power on the grid, prices are only going to rise. So that's when we consider it a villain. A data center hero is by being responsible for their own power requirements, creating its own energy, exporting energy back to the grid to help lower costs, being a resilient part of the grid as well, if you're connected to the grid, so that in the event of problems due to some issues with renewable tech on the grids, these microgrids are going to act as inertia-based plants, and they'll also allow for the growth of renewables. And the hero is, when we design a microgrid at AVK, we're always looking to look at the future fuels. So we're not looking, at the moment we are on natural gas, which is a fossil fuel, and this is purely because of fuel delivery, but we are ready for hydrogen. A combustion engine, a reciprocating engine will burn most fuel types. If we've not got embedded carbon in there, the outcome is better for everyone. Turbines will use hydrogen. Fuel cells, you need the selection correct, but it's about, telling the environmental agencies, all of these people that, yeah, we are on natural gas at day one, but we're ready to move to a future fuel. So, we want to be part of the solution, not the problem. And it's also adding in all of these district heating, carbon capture utilization, carbon capture storage, trigeneration, and emission control. So this all reduces our carbon footprint, reduces emissions, and we're also helping to reduce energy prices. And we're going to try and help the local community, where the data center may be, by giving them, district heating. Sure, the network might not be there for district heating, but if we don't start planning for this, this is never going to happen. We've got to be really part of the solution, So really, this is just part of, at AVK, we carry out quite a complex series of funding models. So AVK can fund, we can just build, we can engineer the solution, the microgrid. But basically, you've got models here that, when the utility price is low, you can use the utility. When the utility price is high, you can run the the data center from the energy center. We can capture the carbon. We can use that for carbon capture utilization in the food industry. And we can also support the grid if we've got a grid connection, or we can run as a completely island mode power plant. So the key criteria we sort of think about is, when we're looking at a microgrid, is expected load, megawatts and MVA, the load steps, so the application of load to the microgrid, the emissions from the microgrid, the fuel types we want to think about, the ancillary technologies, carbon capture, trigen, network availability. Do we have 10 MVA of network connectivity that we can actually help the grid with? And can we use that 10 MVA to balance the microgrid? The efficiency, the operation, and one of the key is the phasing of the microgrid. If you build 100 MVA microgrid and in island mode, and you only have 1 MVA of load, it's not a good engineered solution. So just to sort of give you some ideas on this, we've got a phase system. So in initial phase, we put in 19.6 megawatts, phase 2, 19.6, but these are delivered in phases for each data hall. Rather than asking for 200 megawatts of power, we deliver these in phases. I think I'm running out of time, so I'm going to crash through some of these. Apologies. The impact of load. This is not to be underestimated. Load is everything for a microgrid, especially in island mode. If you don't understand your load, your microgrid will fail. So if you've got no load, that causes problems for certain technologies. If you've got cycling load, that could cause issues. If you've got power factor, if you're going into a leading power factor state, that can cause issues, and the load steps. With the advent of data center AI loads and the training cycles, all of these sort of things, I'm not going to confess to be in the actual white space. I'm an electrical engineer, allegedly. You're going to see load changing, sort of different load platform for these microgrids, and also for the UPS systems, the static transfer systems. You know, there's talk of DC, direct current data centers. So it's really important to recognize the fact that if the load changes, and I will think we're not 100% sure where the load's going, this doesn't only affect your UPS modules, your lithium ion battery systems, your valve regulated lead acid battery systems. This comes right back to your microgrid or even onto your network. If these AI data centers are doing this to the network, we've got to be very, engineering savvy to understand what impact that's going to have. And in summary, really from an AVK perspective, we can use any technology. We're technology agnostic with regards to microgrids. So fuel cells, high speed combustion, medium speed combustion, open cycle gas turbines, combined cycle gas turbines. We do energy storage because you need energy storage to balance the microgrids. We look at renewable technologies. We've got carbon capture. We can do trigen. We can do district heating schemes. Fuel of today is a stepping stone. Because we're using natural gas, it doesn't mean this is the fuel of tomorrow. But I think it's important that we push environmental agencies, all of these people, to say, look, if you don't put in hydrogen ready systems, when hydrogen does come available or a new fuel, you're not going to be ready for it. And most of your plant on the network at the moment is going to, have to undergo severe modifications to get it ready. So microgrids are essential to underpinning the use of renewable energy. Without inertia-based tech, you don't really have renewable technology. You can use renewables just with huge amounts of battery energy storage, but battery energy storage has its own environmental footprint. It's net zero for the production of energy, but for the manufacture of cells and things like this, they're not net zero. Concept stage design and planning is essential to understand what you're looking for, how you want the microgrid to work, and the type and load profile is crucial to validating any concept during the design stage. So it's about working in partnership with the client to develop a microgrid and then going through the roadmap into the planning, permitting stage, secure the power asset. And so you're designing a microgrid not for the load. You're not just saying, I want 100 megawatts. You're saying, this is what my load looks like. And then you design the microgrid around it. And I think, Jordan, that's me done. I'm not sure if I'm early or late.
You're slightly early, so if you had anything else to add, that'd be fine. If not, that's not a problem. We don't currently have any questions, but firstly, I just want to say thank you,
No
Bob, for that
worries.
session. I know it's quite a complex subject, microgrids, and yeah, it can be hard to distill it in plain English. I think is the
Yeah,
term I
we're
want to
seeing a
use.
huge amount of activity in the US for microgrids, for turbines, combustion engines being connected onto the network to support their AI boom. And I think I was reading recently that the US economy is basically being supported at the moment by AI growth.
Yeah.
You know, if that AI growth wasn't there, then there's a possibility we could be, in a bit of trouble in the US. And microgrids are being deployed throughout the US. And I think it's important we need to start, talking about these solutions, because we don't want to get left behind.
No.
Europe.
And I think that's been the theme of today in terms of the US is a bit more advanced on many things when it comes to AI. And it's about time we start to take the learnings from what's happening in the US and sort of applying them to our own scenario. Well, not necessarily taking a copy and paste approach, but also um, seeing what works over there and how it can translate over
Yeah,
here. And I think microgrids is a good one.
yeah, absolutely.
And we do actually have a question. What sort of footprint would a microgrid require? Is there a nice ratio of microgrid to data center as a rule of thumb from Jordan Tolson?
Unfortunately, it's all technology dependent. So if you went with a fuel cell, so a solid oxide fuel cell, they've got quite a big footprint. So a solid oxide fuel cell is an electrochemical reaction, and you get DC output out of it, and you put inverters and everything. So they're slightly larger footprint. Probably the smallest footprint is an open cycle gas turbine with high speed balancing gas engines, which gives you a nice compact footprint, or the big medium speed engines. But unfortunately, it's not until you start looking at the key criteria for the microgrid that you understand is what do we have to do on the
Mm.
resiliency? So do we have to put in a maintenance asset and a failure asset? And then do we have to have concurrently maintainable switchgear to keep us up at the tier 3 level? When we're working on actual critical power microgrids at the moment. So, these will actually, provide critical power as well. We're also looking at some DC microgrids at the moment. So, no, unfortunately, there's not a standard metric per footprint per megawatt.
There's no one size fits all. That's the
I wish there were.
approach. Yeah, it would make everyone's life easier. I imagine it would make your job a lot easier. But obviously, there's different solutions for different problems, and for different sites as well. Like some sites may work for one generation asset better than others. It's just taking what that site is best for, I think, and what the connection in terms of what it's being connected to needs best.
Yeah,
That is our only question. So you get 5 minutes back of your time. Um, Thank you very much for that presentation, Bob, and thank you for joining us today.
no problem. Thank you very much.